We're starting a unit on something called rational expressions, which basically means I have a whole lot of fractions going on. And the main idea we're going to look at is that if I factor something, so here I've just factored some happy little equation, I can cancel or reduce to 1 if I have the same factor in the numerator and denominator. So notice right here, I had an x minus 1 in the top and the bottom, so this reduces to x plus 3 over x plus 1. We'll get a lot of practice in problems like that. But we do need just that little skill of being able to cancel the top and the bottom for this first problem. So notice, not only do I have this big fraction going on, I have little fractions. You see I have little fractions going on? When we have the big fraction and the little fractions, we call this whole thing a complex fraction. Now, that probably makes sense to you because you look at this and go, oh my gosh. So what we're going to do is multiply by the baby denominators, or the little denominators. So I'm going to multiply this whole giant fraction by a version of 1, because I can multiply anything by 1, right? So I can multiply something by 1, or by 2 over 2, because 2 over 2 reduces to 1, or 4 over 4, that reduces to 1, or x over x, that reduces to 1. So some sort of special 1 I am going to multiply by. And the special 1 I decide to multiply by is my baby denominator. So I notice here I have two different baby denominators. I have 4 and I have 2. Well, what's handy is that 4 is a multiple of 2. So I'm going to choose to do 4. So I'm going to multiply by this giant 4 over 4. And I'm going to distribute that to the numerator and the denominator. Are you taking a deep breath? Take a deep breath. All right. I'm going to erase these. And notice I have this 1 right here. It didn't have a denominator, so I put it over 1. So let's carefully distribute this. And in this one step, all of a sudden stuff is going to get simpler. I promise. If I do 4 times x over 4, guess what happens? Those denominators cancel. That's the entire point. Then I'm going to do 4 times negative a half. Well, that just simplifies to x minus 2. Now I'm going to go to the denominator. 4 times x squared over 4. Well, those denominators cancel, so I get x squared. And then I have 4 times negative 1, which just gives me negative 4. Oh, I didn't need to make that a little fraction. That's okay. All right, I'm actually one step away. What I notice is that this denominator is a happy little difference of squares. Woo! Do you remember difference of squares? If you got 2 terms perfect squares, subtraction in the middle, let's go from there. Put your parentheses 1 with the plus, then a subtraction. Yes, you must. Square root of the first, weaky, square root of the last, keep them in order and you're done fast. All right, now look what I have. I have an x minus 2 in the top, x minus 2 in the denominator. So those reduce to 1, so I have a 1 in the numerator. Who's left out? Hanging in the denominator is x plus 2. So this giant hot mess that I started with actually is equivalent to 1 over x plus 2. So we are multiplying by the baby denominators. So let's try multiplying by the baby denominators here. How do I know I'm doing this process? Because I have a big fraction and then I have little fractions. So we're going to multiply this giant fraction by the baby denominator. So I notice I have a y in both, but I also have a y squared. So I'm going to choose to multiply by y squared. Okay, if you think back in your life to middle school, least common multiple, that is what we're doing, finding the least common multiple. So now we're going to carefully distribute. 1 times y squared is y squared. Then we're going to distribute here 2 over y times y squared. What's going to happen is your y in the denominator is going to cancel, and I'm left with 2y. Let's distribute in the denominator 3 times y squared, nothing interesting there, minus, when I do the 4 over y squared times y squared, they cancel. The whole point of doing this by the little denominators is that your little denominators cancel. So now, believe it or not, this gross thing is my answer. But at least it doesn't have all those fractions that you had in the first one. Okay, last example. So I see I have big fraction, little fractions. So I'm going to multiply by some sort of special one. And the special one I'm going to multiply by is the little denominator. Well, what's in my denominator this time? I have an x plus 4. Miss Vance, what if they aren't the same? They're going to be the same right now. Okay, this year they will be the same. All right, so now we're going to distribute this whole thing of x plus 4. Don't make your life complicated. The whole point of multiplying by the little denominators is so they cancel. So when I multiply x plus 4 to 5 over x plus 4, guess what I get? 5. The end. That's it. They cancel. Minus, I'm going to write down this 2, and now I'm going to multiply 2 by x plus 4. I need parentheses. We're not going to distribute that in your head right now. Okay, now we're going to multiply the x plus 4 to the denominator. What's the entire purpose of multiplying by the little denominator? So they cancel. So the x plus 4 and this x plus 4 are going to cancel, and I'm left with 1. Plus, I'm going to write down my 3. And when I distribute the x plus 4 there, we're just going to put parentheses x plus 4. And now we're going to distribute and combine like terms. So I'm going to stop writing quite so ginormous. 5, distribute your negative 2, minus 2x, distribute again, minus 8 over 1 plus 3x plus 12. So that gives me negative 3 minus 2x over 13 plus 3x. Your exact order in the numerator and denominator doesn't matter. And you may be wondering, well, why aren't you doing that factoring thing you did on the first slide? Because most of these problems aren't going to require further simplification. That first one was actually an exception, which I should never start with an exception, but I did. It's okay. Take a deep breath. You can do this.